6.2 is about finding inverses. So when you're given coordinates, it's pretty easy to find the inverse. All you do is take every xy coordinate and x and y trade places. So -7, 1 is going to become 1, -7. 0, 5 is just going to become 5, 0. 5, -1 becomes -1, 5. So all you do is make x and y trade places. Okay, I'll let you guys do the next two on your own. I'm going to do number 5 before I do number 4. Okay, so the steps are at the top. So the first step is you replace f of x with y. And then x and y just magically trade places. So that y becomes x, this x becomes y. Now you solve for y. Before I solve for y, I'm going to make them trade sides, because what you're solving for, you want to be on the left. So then we get y equals, and how do I make this 3 go away? I multiply by 1/3. So 1/3 times 3 is 1, and we have y equals 1/3 x. And then let's write it in function notation. So the way you write the inverse, it looks like f to the power -1. The way you read this is f inverse of x. So I'm going to write it with f inverse of x equals 1/3 x. Alright, so now they want us to graph the function and its inverse. So going to my graph, the original has a slope of 3 and a y-intercept of 0. If you recall slope-intercept form, y equals mx plus b. M is the slope, b is the y-intercept. So we start with a y-intercept of 0. The slope is 3. So I go up 3, right 1. I don't have room to do that again. So to go the other way, I'm going to go down 3, left 1. And then I draw a straight line through that. Alright, so to graph the inverse, there's two ways to do this. One, you could just use slope-intercept form. So the m is 1/3, the b is 0. So I go to 0, 0, and I go up 1, right 3, down 1, left 3. Okay, one way to check your answer, if you think about the line y equals x, that's the diagonal line from bottom left to top right. The line y equals x should look like a mirror of the two. So if you kind of tilt your head or tilt your paper, the two functions should look like mirror images of each other. So that's a way to check your answer. Alright, so for number 4, you can't really do the steps listed above because there's no x. So first let's graph y equals 4. Y equals 4 is just a horizontal line that goes through 4. So going back to number 1. Number 1, we just took coordinates and then we said the inverse is where x and y trade places. So pick any 2 points on the line that we just made. So if I pick this point, 0, 4, so the inverse of 0, 4 is 4, 0. Let's pick another point on the original. That point is 2, 4. So then I know that the inverse should have 4, 2. Once you have 2 points, you know that a straight line has to go through those 2 points. So we graphed the original, we graphed the inverse, we didn't say what the inverse is. A vertical line has an equation x equals, so this inverse is x equals 4. And if we want, we can draw the mirror. So the line y equals x, does that look like a mirror? So does the blue line look like a mirror image of the red line across that diagonal line? Yes, it does. Okay, so now I'm going to move to number 6. So I change f of x to y. X and y trade places. I'm going to move y to the left side. And then I want to write my final answer in function notation. So it's f inverse of x equals x minus 2. Okay, graphing the original, it has a y-intercept of 2 and a slope of 1, so it's going to go up 1, right 1. And might be a good idea if we label these. This one is f of x. Going back to number 5, this one was f of x. Alright, now I'm going to graph the inverse. So this one has a y-intercept of negative 2, and it also has a slope of 1. And this one was f inverse of x. Labeling the other one, this is f inverse of x. And if you draw the mirror, you can tell that those two lines are mirror images of each other across that line. Alright, I'm going to show you guys a shortcut now. So, if you don't like that long list of steps, you could just look at the equation. Looking at number 5, just think about it. What's happening to x? It's being multiplied by 3. Well, what's the inverse of multiplying? Dividing. So I can just look at it and say, okay, the inverse of 3 times x is 1/3 times x. Or the inverse of multiplying by 3 is dividing by 3. And dividing by 3 is the same as multiplying by 1/3. Alright, going to number 6. What's the inverse of adding 2 to x? Subtracting 2 from x is the inverse. So this one had x being increased by 2. Over here we have x being decreased by 2. Let's try to apply this shortcut. Alright, so the shortcut is a little more difficult when there's 2 things happening to x. So I'm going to go ahead and write g inverse of x. Alright, so let's think about what's happening to x. It's being multiplied by 2 and then subtracted by 1. So again, x is being multiplied by 2 and subtracted by 1. So we have to inverse those and in reverse order. So what's the inverse of subtracting 1? Adding 1. What's the inverse of multiplying by 2? Dividing the whole thing by 2. So that would become 1/2 x plus 1/2. Okay, graphing the original. The original has a y-intercept of -1 and a slope of 2. So up 2 over 1 as many times as you can fit on the graph. Down 2, left 1 is how you go the other way. Alright, so that's our original, which is g of x. And now the inverse has a y-intercept of 1/2 and it goes up 1, right 2. Alright, so if you try to graph this, it has fractions. So maybe a better way to graph the inverse is find a coordinate and then inverse the coordinate. So we see that 1, 1 is on the blue graph. So the inverse of 1, 1 is still 1, 1. I also see that 2, 3 is on the blue graph. So the inverse of that is 3, 2. And all you need is 2 points to graph a line. And we know that the slope of the line is 1/2. So we can go up 1 over 2 from all our points and go down 1, left 2 to go the other way. And again, if you want to check your answer, draw the mirror, and it looks like those two are mirror images of each other, and I just need to label the inverse. Okay, so for number 8, what is happening to x? So I'll do this one both ways. So change h of x to y. X and y trade places. Now solve for y. The way you would solve for y is multiply both sides by 4. So if I multiply that by 4, I get y. If I multiply x by 4, I get 4x. And then change it to function notation. So that'll h inverse of x equals 4x. So using the shortcut, what is happening to x up here? X is being divided by 4. So these are the same thing. So x is being divided by 4. What's the inverse of doing that? Multiplying x by 4. Okay, graphing the original, we have a y-intercept of 0, and the graph goes up 1, right 4. The graph also goes down 1 and left 4. This is the original h of x, the inverse would be also starting at the origin and up 4, right 1. To go the other way, down 4, left 1. Draw a line through that. This one is, oops. This one is h inverse of x. Okay, for the last one, let's try the shortcut. So what is happening to x? It's being multiplied by 2/3, and then it's being increased by 2. So if you're doing the shortcut, you're going to do the inverse of both of those. So what happened? It got multiplied by 2/3, and then it got increased by 2. And you have to go in reverse order. So what's the inverse of increasing it by 2? Decreasing it by 2. What's the inverse of multiplying by 2/3? Multiplying the whole thing by 3/2. So the inverse is 3/2x minus 3. Alright, so to graph those, we're going to graph the original first. It has a y-intercept of 2. And the slope is up 2, right 3. To go the other way, we go down 2, left 3, and we draw a straight line through those. Alright, so these aren't in function notation, so I'm just going to call this one y. And I guess I can call the inverse, I'm going to put an apostrophe above the y. So I'm going to call the inverse y prime. Alright, so to graph that one, it has a y-intercept of -3, and the slope is 3/2. I go up 3, right 2. And I taught you guys the mirror method for checking your answer. You could also check your answer by just checking a few coordinates. That's 0, 2, so the inverse should have 2, 0, which it does. That is 3, 4, so the inverse should have 4, 3, which it does. Alright, so to summarize, there are 2 ways to find the inverse equation. One way is to follow these steps. The other way is to just think about what's happening to x and do the inverse. And if there are 2 things happening to x, well, in the original you use order of operations. So then in the inverse you have to do those inverses in reverse order. There are also 2 ways to check your answer. Remember the mirror method, and also remember that you could just reverse the coordinates.